I'd like to solve the following quadratic equation by factoring. Having a leading coefficient of 15 makes it difficult to factor. So I'm going to use my algebra skills to remove that 15. I see that 15 is also a factor of 60. So I can go ahead and divide everything by 15. But to keep my equation balanced, I have to do it on both sides. Now when I simplify, 15 divided by 15 is 1. 60 divided by 15 is 4. And 0 divided by 15 is 0. And of course I don't need that 1 because 1 times x squared is just x squared. And I'm left with a simpler problem. Now when I want to factor this, if I like, I can use a tic-tac-toe method or any other method of factoring is fine. My a value is 1. There is no b value, but my c value is negative 4. A times c, negative 4. I'm trying to add to b, but there is no b value here, so I know it must have been 0. So I need two numbers that multiply to negative 4 and add to 0. So it's 2 and negative 2. Now these are my x terms. My greatest common factor here is 1. My greatest common factor here is 1. My greatest common factor here is 2. And here is 2. But I need these to multiply to negative 4. And these need to multiply to negative 2. So this one must have been negative. So my factors are x minus 2 and x plus 2. I can go ahead and check that I factored correctly. Because if I have x minus 2 times x plus 2 and I FOIL that out, I notice that my middle terms, when I combine them, cancel out. 2 minus 2 is 0, and I'm left with x squared minus 4, which is what we started with. Awesome, I factored correctly. Now I can use the zero product property to solve my quadratic that is in factored form. The zero product property tells me if I have two things being multiplied together and they equal 0, that one or both must have been 0. So either x minus 2 is 0 or x plus 2 is 0 or both. When I solve this, I know that x equals 2. And when I solve this one, I know that x equals negative 2. So my zeros, my roots, my solutions, my x-intercepts for my original equation are x equals negative 2 and x equals 2.